This deck is available for download both at SpeakerDeck and linked to on the QCon site. No need to take copious notes. My Twitter handle is also on this slide. I'm going to pause now for 15 seconds so you can all take photos, because this information is not on the other slides. All right, 15 seconds was about right. I counted to 15, and I see the phones are all down now. A lot changed in Java 9. We got Jigsaw as a new feature, and a number of other new features. Jigsaw was great because it let us make jokes about jigsaw puzzles, and there's no need to be puzzled about Java 9. Before we go any further, we're going to do a little survey to see where the room is at right now in production. I'm not going to ask if anyone's on Java 11 because it comes out in September. If anyone's on production with Java 11 Early Access Edition, I feel sorry for you. Is anyone on Java 10 in production? Okay. 9? 8? Ooh, lots of hands. 7? 6? Oh, good, no one's on 6. We're on Java 8 as well. That's the most common release that people are on in production, and there's a good reason for that. Java 9 and 10 are not long-term support releases. A lot of us here in New York work in the financial sector, where being on a long-term support release is really, really, really important. Java 11 is the next long-term support release. While it comes out in September, it's good to start learning about it now so that we can all be ready and take that back to our teams. Since a lot of us are on Java 8, we don't necessarily know everything that's in Java 9. This is not a Java 9 presentation. I have one slide on Java 9. It's a jigsaw puzzle. Yay. There's a number of cool features in Java 9, including the ability to say that something has been deprecated since a certain version, or more importantly, to say that something is deprecated and will be removed eventually, unlike all the other stuff where it's deprecated and then it's with you forever. There's also, you're able to search the Java doc, there's some syntax sugar, there's more stream APIs, there's a lot of cool stuff. And my presentation on what's new in Java 9, beyond Jigsaw, is also available on SpeakerDeck. It's linked to from the first presentation, so you can read that later at your convenience if you're looking to learn about Java 9. However, today, we're going to be talking about Java 10 and 11. The first half of the presentation is about the ecosystem changes, naming, dates, everything that you need to know for planning purposes. The second half is about actual code, what's in Java 10, 11, and how to use it. A little bit about me. I've written 3 books about Java, Java 8, but we will be updating it for Java 11, so no time like the present to start becoming an expert on Java 11. And I've been a Java developer for the past 16 years. Meet Duke. Duke is the Java mascot. Are you all familiar with Duke? He's cute, right? Well, Duke's been around for a while. He's got a bunch of memories. In particular, he remembers the old days of Sun. We had 6 versions of Java in 10 years. Then Oracle took over in 2010. Hi, Oracle. And then we had a release shortly after that. We can probably give Sun some credit for that. But in 2011, Java 7 came out. And then we had releases every 2 years. Yep, Oracle claims that's every 2 years. According to me, it's every 3 years, but Java 9 did come out in 2017. It had a little bit of a history. Remember that jigsaw puzzle feature we were talking about? It has been in the works, believe it or not, since 2011. In 2011, Oracle was thinking about whether Jigsaw should be included in Java 7 or not. The answer was not even by a long shot, no design, no desire to try. All right, no problem. It'll be in Java 8. Nah. In 2014, they committed to Jigsaw was going to be a part of Java 9 no matter what. And we all know how that turned out. Java 9 was released in September 2016. Java 9 actually had 4 release dates, all 4 of which Oracle committed to that was going to be the date that Java was released. This is a problem. As developers, we need to know when software is going to be released and not make plans around a myriad of release dates for the same product. While Jigsaw was, in fact, in Java 9 and was, in fact, released in September 2017, we can do better. Now, Duke, on his little trip down memory lane, learned how to count. Unlike us, Duke learned how to count in decimal. 1.1, 1.2, 1.3, 1.4. Who knows what comes next? 6, 5. Someone said 5. 5's pretty close. It was 5.0. After that was 6. At which point we resumed a normal counting model, straight up through 11 and presumably 12 and 13. Which means after 6 versions of Java, we now count like normal people. Woohoo! Duke also learned another way of counting, using semantic versioning. That represents the year and month that the version of Java was released. It's not being used as the primary release number, largely because Java developers didn't like it. It's still there behind the scenes, it's still there in Oracle's JDK. Using our 6-month release model, Java 10 was released in 2018 in March. Java 11 was released in 2018 in September. Who knows what the semantic number is for Java 12? Yes, 2019.3, correct. And we can predict these out as far in advance as we'd like. Wait a minute. You mean there's going to be a major version of Java every 6 months? Couldn't even handle a major version every 3 years. Half the room's still on Java 8. What do we do? It's not really a major version. It's called a major version, but it's only got 6 months of functionality in it. Think Agile. We know we're releasing more often. My Agile project releases every 2 weeks, not every 6 months, but it's more often than every 3 years. The reason it's a major version is so that we can have language changes. You can only change the syntax if there's a major version, which means the solution to this is we'll just declare all versions major versions. Now we can change the syntax whenever we want. Yeah, that seems reasonable. But there are smaller features. Like any good Agile project, you carve things up until they're manageable, which means we will not have the saga of Jigsaw ever again. If your feature isn't ready for a release, it waits for the next one. If it's not ready for that release, it waits for the next one. If it's too big to get in any release, you will never see it. That means it's on the developers in order to make features that are small enough that can be inside of a release. Java 10 actually had 12 new features in it. Some of them were small things we care about. Some of them were not so small things we care about, but not large things. And some of them we don't care about at all. They just set the stage for bigger features down the road. Java 11 had 15 new features. Again, some we care about, some that set the stage for other things. Now back to Duke's trip down memory lane. Duke was a student in elementary school. He went to Java school. Okay, let's see how Duke did at Java school. Duke's first subject was developer community. Duke did pretty well on developer community. He got an A. We've got a good developer community here in the room, online. I think it's fair to say that Oracle did a good job with developer community. And we've got features. Java's got lots of features. In fact, the only thing that was stopping Duke from getting an A in features is that a language can always have more features. Or according to Josh, too many features. But either way, you can always add more. So B. But that's pretty good. Duke's a good student. All right, let's continue on with Duke's report card. Duke has frequency of release as his next subject, and for that, he got an F. Duke. That's that every 2-year thing. We couldn't even get to 2 years. It was 3 years. That's not frequent by any stretch of the imagination. All right, it's okay, Duke. It's just one subject. You'll do better in the next one. Now we have predictability of release. Well, he did better. We don't have predictability of release either. Releases were, well, when they were ready, they got released. Here's your version of Java. Clearly, Duke needs to do better on this. And you know what? This isn't really fair to Duke. Because the JDK isn't just about Java. It's about a whole bunch of languages. Duke said, OK, I'm going to go to JVM College. Now let's see how Duke did at JVM College. The first subject was vocabulary. Duke learned lots of new words in college, including polyglot programming, so he could support all these new languages on the JVM. All right, good job, Duke. Learn a few more words, but you're doing OK. Then we've got polyglot programming itself. Well, we have Kotlin, we have Scala. I think Duke did a good job here. Duke got an A. All right, now we're back to, oh man. Believe it or not, this is worse than on the prior slide, because now in addition to holding up Java, we're also holding up all of these other languages. Something's got to change. And you know what happens at a company when you have a change? You have a reorg. Yep, time for Java to have a reorg. We're going to have a reorg at the train station, and we're going to reorg the release train into something that makes sense. But first, another survey. We're going to see how many languages people know. I bet it's not just Java. And remember, all of these things are programming languages, so if you only know Java and HTML, you know more than one programming language. Raise your hand if you know 1 or 0 programming languages. The camera guy. All right, I'm glad everyone else in the room knows a programming language, otherwise you'd be in the wrong room. Who knows 2 to 5 programming languages? Okay, 6 or more? All right, and this is the message, that we're all polyglot programmers now. Nobody can get away with just knowing one language and making a career out of it. And Oracle recognizes this. So the first thing in the reorg was you change the names of everything, because that solves all your problems. You know we all work at big companies from the laughter in response to that. Java 1 was renamed. It's now called Oracle Code 1. There was also Oracle Code, which was the traveling roadshow to major cities throughout the world. Okay, this was good. This recognizes that it's not just about Java, and it recognizes the fact that Java developers really care about a lot of things. You care about having a rich UI, you care about having a backend, you care about having DevOps, you care about having a pipeline. Even last year at Java 1, it wasn't all about Java. So while people cried when this change came out on the internet, that Java is dying, this is the end of Java, this is the end of Java as much as all the other things that used to be the end of Java were the end of Java. Java's fine. It's an ecosystem. The other change was to Java Enterprise Edition. Oracle decided that it would be better for the community to maintain Java Enterprise Edition and make it better. But being Oracle, they have a lot of lawyers, and you're not allowed to use the word Java. No problem. The new name is Jakarta EE. Cleverly, still JEE. There is a lot of discussion in this space right now about what's going to happen with things like the package names and how to deal with it. But for the time being, it's alive and well. It's in Jakarta EE and ready to go. All right, we've got all the names out of our system. Now we can move on to the stuff that actually matters. The release schedule. We saw Duke didn't do very well before in his classes on frequency and predictability of release. And the reorg really solves this. From now on, there are going to be releases on a schedule. And it's an actual schedule. It's just as much of a schedule as the patch schedule, where you can predict in advance when something's going to be released. There's going to be a major version of Java every 6 months, as I mentioned. And there's going to be a long-term support version of Java every 3 years. Those are the version that we enterprise customers care about. That's the version that's going to be stable and have security releases on a regular basis. Releases are now feature-driven. Because the date's known in advance, if your feature didn't make it in by the date, it goes on to the next release. On a related note, today is feature complete day for Java 11. What you hear today is what's in Java 11 is what's in Java 11 and final. Very cool. All right, now that we know when our releases of Java are coming out, developers don't have to waste time checking and replanning. They can code right up until the day that the train shows up, and they're good to go. Any good train station has a schedule. Java is no different. Java 10 came out in March. Java 11 will be coming out on September 25th of this year. And as I mentioned before, Java 11 is the next release that has long-term support. We should all be ready for that to come out so that we can start planning for it. Just like an arrival schedule, you also need to have a departure schedule. Most of us, or almost all of us, are on Java 6, 7, or 8. Java 6 loses its support even for paid customers at the end of the year. It was good to see there were almost no hands for Java 6, but if you know anyone who's still on Java 6, remind them that they need to be getting off like now. Java 7 will have long-term support through 2022 as a paid customer. It's a good while from now. Java 8 is interesting. It still has public patches for a while. Those public patches, according to Oracle, end in January 2019 if you're a business customer, and December of 2020 if you're an individual customer. This makes no sense because it's the same patches. I don't understand how they think they're going to enforce that or how it's going to have meaning, and I look forward to seeing a clarifying announcement on the topic. But personally, it doesn't affect me because as an enterprise customer, paid patches last until 2025, and there's plenty of time without having to worry about it. Java 9 and 10 do not have any paid patches. You cannot pay any amount of money and expect to get security patches after the public patches end. The public patches are available until the next major version of Java comes out. Right now, Java 10 is the current version. If a security issue is in the news tomorrow, there will be a security patch to Java 10. There will not be a security patch to Java 9. If you're on Java 9, your upgrade path is congratulations, you're now on Java 10. If a major security issue comes out in October and you're on Java 10, similarly, your upgrade path is congratulations, you're now on Java 11. If you're paying for long-term support and an issue comes out anytime after March 2019 for Java 11, you will get that paid support. You will be able to keep downloading patches. This applies both to the traditional you give Oracle a lot of money less often and to the new subscription model. The schedule of when you get your support until is the same. You might notice there's 2 dates on there for 2011, for Java 11. The reason for that is there's different levels of support you can pay for. If you pay more money, you get longer support. All right, let's see if we've all been paying attention. How many months will Java 12 have security patches for? All right, everybody's awake. 6 months. And remembering that long-term support releases come out every 3 years, when is the next one after Java 11? Okay, I heard both. I heard a year, and I also heard the number. The number was what I was looking for, Java 17. We've got 2 releases a year for 3 years. We add that to Java 11, we get to Java 17. Once we get to Java 11, we get to sit on it for a while, relax, and enjoy what's coming next. Next up, we have a tale of 2 JDKs. There are 2 JDKs. Well, there's really more than 2 JDKs, but on this slide, there's 2 JDKs. There's the Oracle JDK, which only exists for those LTS versions, the Java 11, Java 17. Oracle's not putting out a JDK for Java 12. If you want a JDK for Java 12, you get it from OpenJDK. OpenJDK is putting out a version of Java every 6 months. It's great. OpenJDK is also free. And as we mentioned earlier, if you're on Oracle JDK, you can upgrade to security patch versions. You can upgrade to the next 3-year version. You can also switch to OpenJDK, but of course, once you switch, you're subject to the OpenJDK security updates and not the Oracle ones. OpenJDK provides interim security patches within the 6-month release window, and then you get to upgrade to the next version. As I mentioned earlier, today is Feature Complete Day. Woohoo, we get to know what's in Java 11. And there were changes right up until Feature Complete Day, the most recent one being on Monday. I'll show you later in the presentation which feature was added on Monday. This really proves whichever features are ready before Feature Complete Day are what make it into the next version of Java, and nobody knows that in advance. It depends on each feature to defend itself as being ready. I like to play with different versions of Java on my machine, and OpenJDK makes this really easy. Raise your hand if you're on a Mac. This was fun with Oracle JDK. They gave you a DMG image, and if you wanted to have multiple versions of Java, it was, well, you used a virtual machine. With OpenJDK, they give you a tar.gzip file, which is much easier. You can download as many of those as you want and just have them in parallel directories. On my machine, I like to use aliases for all the versions of Java I have. So I can run commands like Java C11, Java C10, Java 9, you get the idea. This allows me to switch really quickly between different versions of Java. If I'm testing behavior, I want to know if the same code compiles or runs in different versions of Java and how it behaves. It also makes it obvious to me what version of Java I'm running. If I'm playing with Java 11 for my pet project or this talk, but then I'm going to work on the Code Ranch software and I don't want to be on Java 11, I don't want to make any mistakes, and by having to explicitly say what version of Java I'm on, that prevents it. We're now halfway through the talk, and we get to go on to actual code, the new features that are in Java 10 and 11. The first one is local variable syntax. Local variable syntax is a bit of syntactic sugar. It allows you to use the keyword var. It's not really a keyword, we'll get back to that later, but it lets you use the word var as a substitute for a type name. I had a nice debate with somebody over lunch. Spoiler, I was right, I wrote this presentation, about what var means. var does not mean immutable. It also doesn't mean what you would expect in a scripting language. In this case, var is a string. It's just less typing for me. It compiles to the exact same thing. Similarly here, I have a list. var is now a list in this case. I can't say later var list equal 3 because that won't compile. I've established that list is a list and not an integer. I have to treat it as one consistently. This is so that you can type less. There's pros and cons to typing less. It is not immutable. There's no val. Maybe there will be in the future. But there's no val in Java 10. You're not getting new functionality here. You're getting code that's shorter to type, easier to read, and easier to show in presentations. And remember, it is the type it is. So in this case, name is a string. I get to assign it to a string variable on the next line of code without having to cast or do anything funky because the compiler knows that name is a string. Next up, we have a little bit of code I wrote for a robotics program. Here the types are a little bit long. And it's even worse on a screen where you're presenting because the font type is huge. I can rewrite this with var. This has a few advantages. One, in a presentation, I let you see what's really important, which is not the type. Two, the variable names align, which makes it easier to see what's going on. And three, I don't have any unnecessary fluff. It's a pretty good bet that header row is a row object. I don't really need to have the type right before that to remind me. Another example where this is useful is when you have code that's really narrowly scoped. If I forget that the CSV path is a path object, I need to study Java a little more. The fact that it says path there isn't going to help me. And if you think about the typical path code, we have something like path equal paths.get blah, 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 blah. Yeah, I get it, it's path, right? That's not helping me. It's also only saving me one character, so we're back to the pros and cons. But for things that are longer, like my buffered reader or my CSV printer, I can tell from the name of the object what it is. I'm fine here. There is some historical precedent for this syntax sugar. In Java 5, when we first met generics, we had to write a lot of code. We had to use the generics on both sides of the equal sign. Java 7 made that better and introduced the diamond operator. We then only had to put it on one side of the equal side. Unfortunately, it was the wrong side. It would be much easier if it was on the other side, so I could read the type more easily. And with Java 10, I can. So it took us a while to get here, but this code is more readable, and it conveys the exact same information. If I want to know what product map 3 is, I have to go to the line where it's defined, and it's still there. So I haven't lost any information. I've just made it a little easier to read. Let's take a look at where we can use var. We can use it as a local variable. Good. We can use it in a local variable where the compiler can determine the type, for example, in an assignment. We can use it when we're calling a method and the compiler can determine the type. Noticing a theme here. We can use it inside a loop. Where can't we use it? As of Java 10, you can't use var inside inner classes. Not terribly surprising because it's local variable syntax, not instance variable syntax in inner classes. We cannot use it if we haven't defined the value. Even though no good is defined later, it doesn't know what that is. And I realize this wouldn't compile anyway because I didn't write equal null. But even if I had written equal null, that wouldn't be enough information for the compiler, and I'd still have issues. Can't be used in instance variables or any other creative place that you're thinking of. Now for a question. We're going to do a little thumbs up, thumbs down poll. If you think this compiles, do thumbs up. If you think this doesn't compile, do thumbs down. Got a nice mix here. I think it's about 50-50, which means half of you are tricked. This code does compile. It compiles because var is not actually a reserved word. Think of it like a type. I know. There are only two places that this code should exist. A certification study guide and when Josh updates his puzzlers book. This should not exist in your code. It's actually important that this compiles, though, because var was a perfectly good variable name up until recently. Technically, it still is, but now you know it's a bad idea to use it. If you've got legacy code that has a variable named var, you don't want it to stop compiling when you upgrade to Java 10. And since Java and Oracle value backward compatibility, this is a perfectly reasonable thing to expect to happen. What you don't want, of course, is writing code where you've got var 2 or 3 times in the same line. That's just silly. If you wrote this code, it's in Java 10, and you already know you shouldn't use var. But it's a fun thought experiment, so I included it on the slide. Reviewing the pros and cons of using var, we've got less typing at the cost of less information. We've got less redundancy if you're careful with your variable names. Please don't use Hungarian notation. If you're using Hungarian notation, you shouldn't be using var. And you can scan the variable names more easily. But like any good thing, this is rope you can hang yourself with. In the presentation we saw earlier today, we had a website with good references to when you should and shouldn't use var, so I reused / stole it for my presentation. In Java 11, they added another feature for var. And this really shows that when you have features that are delivered incrementally, it works just like Agile programming, where you get smaller pieces of functionality. In Java 11, they added the ability to use var with lambdas in addition to local variables. We've got a basic lambda here, p arrow true. We could always specify the type. Here we've got a string, we said what it was. And now we can specify var instead of the type. And I know what you're thinking, this is ridiculous, I didn't need to specify a type in the first place, right? Come on. But that's okay, because there is a use for it. That use is when you want to use an annotation in your lambdas. When you want to use an annotation, you have to specify a type because the annotation requires a type. And in the case of my example, the type is long and annoying, and I do not wish to specify the type. Here, var is perfect. I'm only including the type at all to make the compiler happy. I don't need to read it. I don't need it to be readable. And a perfect use case for this example. It is all or nothing. If you use var in a lambda, you have to use it for all of the types in that lambda or none. You can't leave it out. You can't switch to the actual type. You've got to pick. But not a big deal. You can change it from lambda to lambda, and that's just what you would want to do. Our next topic is garbage collection. We saw earlier that Duke didn't do well in school. And the punishment for that is that Duke has to take out the garbage forever. The first feature is in Java 10. Choose your own garbage collector. There's a new garbage collector interface. And this is a perfect example as a developer of I don't care. The reason that anybody cares is it sets the stage for other features, which we'll be seeing on the next couple slides. And again, the Agile model, you want to deliver small, concrete things, even if they're not necessarily useful to the end user, all of us. They are useful to the language itself so that we can make progress. Up until Java 8, which we're all on, the parallel garbage collector was the rule of the land. Starting in Java 9, the garbage-first garbage collector started becoming prevalent. In Java 11, it's the default with parallel implementation. I'm going to give a one-slide overview on this topic. For more, Chandra wrote an excellent presentation. The link is here. Raise your hand, Chandra. Take credit for this. Yay! This is also Chandra's slide. Garbage one garbage collection divides up memory into regions, so you can have garbage collection happen independently. The one takeaway about garbage first garbage collection is it's about finding garbage, not finding every scrap of memory that can be cleaned up. It's better to get rid of that giant stack of garbage that was on your table and throw it out and leave a little clutter there than have it all there because you're continually looking to see if you've got anything. Besides, in a few milliseconds, you'll have more anyway. There's also in Java 11 the new epsilon garbage collector. This one's fun. It never reclaims any memory. It's the do-nothing garbage collector. The program runs until you run out of heap space. That doesn't seem very useful on the surface, does it? That's why we have a beware of garbage collector on the here. Just like coyotes, beware of epsilon. It does serve one purpose that's important, which is if you want to do a stress test. If you want to know how your program behaves when it runs out of memory, the fastest way to make that happen is to tell the garbage collector, leave me alone and let the program run out of memory. It's also good for very short batch programs. If your program takes 1 second to run, you don't need to clean up the garbage. You may want to just have it run faster and get it over with. It's also used for last-ditch performance improvements, with the exception of possibly one company this probably isn't you. And if this is you, be really, really, really careful. The next garbage collector, also introduced in Java 11, is the Z garbage collector. This one is experimental, still being worked on, and it aims to have 10 millisecond or less pause times. Currently, it's only available for Linux. That may change over time, or it may not. And to use it, you need to use 2 flags. First, you need to use the unlock experimental features. I really know what I'm doing, and I'm not going to blame Java when my program crashes. And then you say you want to use the Z garbage collector. Probably not what you want to do in production. Our next feature is the HTTP client. This is not a new feature. This is a feature that's been in incubation for years. It's now hatched, it's done incubating, and it's ready to be a real full-fledged feature in the language. We now have a chicken. This is an API that allows you to really easily interact with HTTP. So you can get a client, you can get a response, you can get a URL, and you can put it in a string or other object of your choosing. That's helpful. You can also do the same thing asynchronously. I've created a map and a stream, and I've got all of my future objects so that I can get them later. And then I say send them asynchronously, get all of those strings for me, and let me know how it worked out. There's a lot of customization you can do. You can say I want to file an input string or a string. You can also say I want to discard the results. Maybe I'm doing some sort of load test and I don't actually need the string for anything. You can specify a bunch of request options like the header. Proxy is a really useful one. We all work in companies that block everything from the internet. And you've got all of the standard HTTP verbs. Pretty useful as an API. It hasn't changed that much since the incubated version if you were using it. Our next feature is time-based versioning. This is the Java code that goes with all of these changes we've been hearing to the release schedule of the language. You can ask Java what version it's on. You can also ask Java to print out the feature, interim, update, or patch version of the language. Up until now, you could ask Java to give you the major, minor, and security versions. They still exist, but they're deprecated. We're now supposed to use the new ones. And feature, interim, update are roughly equivalent to what they were before. We've added another level of patch so that we can get more information out of Java. I tested this with update number 1 for Java 10, and also early access edition of Java 11 since Java 11 isn't out yet. The feature version is the major version of Java. That's what's updated every 6 months. Interim versions don't apply to OpenJDK because they're only releasing fairly infrequently in the first place within the 6-month release cycle. But for Oracle JDK, they may use it. Updates are when there are updates within a 6-month period. For example, Oracle is planning on releasing update 1 of roughly a month after the first release. So Java 11 comes out in September. There's probably going to be update number 1 in October. And patches are used for emergencies. There haven't been any yet. If there are, they'll start counting with 0. You can also ask Java to give you the date that the version came out. This is the patch version, or the update version, if there was one. Since I'm using update 1, I'm told that my JDK came out in April rather than March when Java 10 came out. For Java 11, it's more interesting. It tells me that my code was built in the future. And it was, because it's an early access edition. This will become true when Java 11 is released. So it's not the build date. It's the date that is logical for a release. Something you need to be careful about so you're not accidentally writing code that has to deal with the future. It's kind of weird. You can also say java.version.version. This is not a typo. It is, in fact, there twice. OpenJDK does not use this. This is meant to be a vendor string. Oracle plans on using the 2018.9 semantic versioning for their vendor-specific string. IBM may do something different. Azul may do something different. We shall see. Our last section is a small collection of odd and end features that made it into Java 10 and 11. One of my favorites, because I mentor high school students, is the new Java launcher mode. When you're teaching someone new Java, you write a Hello World program. Okay. So you type Hello World with all of the ceremony around it, and then you explain that you have to write Java C, and here you need the extension, and then you have to write Java, and you don't need the extension. Don't worry about why that is. Just pretend it's magic and type it in. We no longer have to explain that to people. You can write Java, the name of the Java file, and have it run. This only works if your program contains one class, which means it's really only useful if you're doing a tiny experiment or you're teaching someone new. But let's be honest, once your program has 2 classes, you're using a real build tool and you're not compiling at the command line anyway. What's also cool about the new shortcut is that it doesn't actually create a class file. It does everything in memory and it runs your program, which means we don't have to explain to people class files until they've gotten a little further in the language. So I think this is cool. The practical implications at a company are pretty close to 0, but it's a fun feature and it will be useful for new people. The next feature, which I forgot about until I went to a presentation this morning, is unmodifiable collections. There's now APIs in order to make a copy of or to turn a stream into an unmodifiable list, set, or map. There's another feature behind the scenes, nest-based access control. As we know, when you compile code that contains one class, it generates one class file. If you compile code that has one class and one inner class, you have two class files. And then things start to get interesting. If you have a private instance variable in your outer class, the inner class is allowed to access it. But the inner class is in another class file. So it's not really private. It's private except for the people who are allowed to use it. The implementation of that has always been a hack. And with Java 11, they fixed the hack. Yes, cleaning up tech debt. As users, this is something we really don't care about, but it's nice to know that progress is being made. When Java 9 came out with the deprecated for removal, they removed a handful of APIs. And we're sitting around wondering, are they going to keep removing things, or was this a one-time thing so they could say they removed stuff? And now we know. They are, in fact, going to keep removing things. The old Java EE and Corba modules that were in the JDK itself for some obscure reason are no longer in Java. They are thrown in the trash. Java took it out with the garbage, and we're not going to be seeing them anymore. The next thing is the PAC 200 tools, which are in Java 11 were designated as deprecated for removal. Those were the things that allowed you to create a compressed jar file that had less stuff in it. Since Java 9, that's unnecessary. JLink modules do that for you. Java recognizes that we probably don't need this anymore. It would be good to signal that it's going to go away one day. And as we learned from the previous slide, one day will actually happen. My favorite feature that was deprecated for removal was Nashorn, the JavaScript-ish engine that you could use. I had to write a chapter of this for my book, which got binned because it wasn't put on the exam. Yes. There's no reason anyone needs to know this. It's not Java, it's not JavaScript, and JShell is a million times better. It's nice that they're removing it from the language. Or I should say, might be removing it from the language. The actual JEP says if a bunch of people are really enthusiastic about this and want to adopt it, it may stay in. So far, history has shown that people are not so enthusiastic about this, and JShell will take its place. This is my feature that I was mentioning, was actually made it into Java 11 2 days before the cutoff. On Monday, they announced this was going to be deprecated for removal in Java 11. Not a huge feature, but it proves that if something is ready close to the deadline, in it goes. And finally, we're going to end with a fun feature, Unicode 9 and 10 support. There are, in fact, practical implications for this. If you're writing things in various Chinese dialects, having extra Unicode support is perfectly useful. I do not speak Chinese, so I'm going to be showing you things like giraffes and pretzels. Much more practical in my mind. And to tie this all together, we get to use two new Java 11 features. We have a program here. It's just a main program. It outputs some stuff in Unicode. I run it using Java 11, that alias on my computer, with unicode.java instead of javac and Java. And it tells me that I should have a beer or a soda, but not for another hour because I hope you'll stay for the next panel in this track. To tie it all together, there's no need to be puzzled about Java 9, 10, or 11. We learned about the Java 11 LTS and why we should be ready to go when September comes out and we can upgrade. We learned that there are releases every 6 months, unless you need security support, in which case there are releases every 3 years. We learned about a bunch of new features. So go tell your manager and your team so that everybody's ready for the September release. And with that, I would like to take questions, and remember to say good things about me on your way out the door.